Hello everyone, welcome to my class. In today's class I'm going to cover the parabolas. So let me start the class right away. First let me review what we are studying in chapter 9. In chapter 9 we are studying the geometric shapes formed when a right circular cone is intersected by a plane. We investigate four sections of the cone by a plane called the conic sections. They are circle, ellipse, hyperbola and parabola. In previous classes we learned about circles, ellipses and hyperbolas, and now we explore the fourth and the final member of this family of conic sections, the parabola. Let me scroll down. So in this diagram here, this is the cone and the plane which is parallel to the edge of the cone intersect the one nape of the cone. Then this cross sections is a parabola. So then parabola either opens up or opens down or opens to the right or opens to the left. So next, definition of parabola and the equation of parabola. A parabola is the set of all points, the order pair x, y, in a plane that are an equal distance from a given point. The point is called the focus, and a given line, the line is called the directrix. The quadratic equations y equals to ax square plus bx plus c represents a parabola, and there are two shapes of parabola, vertical and horizontal. So in the vertical means the parabola either opens up or opens down, and in the horizontal parabola means either the parabola opens to the right or to the left. So first, the vertical parabolas. The equations of vertical parabola is y equals to ax square plus bx plus c, and this quadratic equations, after completing this square technique, we can rewrite this quadratic equations equals to a times x minus h outside is square plus k. And then this vertical parabola opens up if this coefficient a is positive, or opens down if the coefficient of a is negative. The vertex of the vertical parabola is at this point, negative b over 2a, comma k. Axis of symmetry is x equals to minus b over 2a, and y-intercept of this vertical parabola is at 0, comma c. Similarly, for the horizontal parabola, the equation is x equals to a times y square plus b times y plus c. And again, by completing this square technique, we can rewrite this quadratic equation in y equals to a times y minus k outside is square plus h. And this horizontal parabola opens right if a is positive, opens to the left if a is negative. The vertex of this horizontal parabola is at h, comma negative b over 2a. Axis of symmetry is y equals to negative b over 2a, and x-intercept of this horizontal parabola is at c, comma 0. I hope you understand these key features of these parabolas. So now let's move on. Awesome. Next, let me visualize the key features of the parabola. So here I chose the vertical parabola. So here in the first diagram, our parabola is opening upwards, whose equation is of this form here, y equals to ax square plus bx plus c, or is equivalently x square equals to 4 times p times y. Then vertex is at origin, focus is at point 0 p, and the directrix is at y equals to negative p. Axis of symmetry is x equals to 0, that is y axis. And in the second diagram, again our parabola is opening upwards. Now this time this parabola is shifted from having vertex is at origin to vertex is at hk. Then y-intercept is at here 0c, Directrix is at y equals to k minus p, and axis of symmetry is x equals to h. And by the way, the focus and the directrix are not actually the part of the graph of the parabolas. So I hope these key features make sense to you all. We have the formula here for the key features and as well as the visualizations here. So next, for the parabola in the focus directrix form, where the vertex is at origin and P designates the focus, the key features are as follows. So the vertical parabola in focus directrix form can be written as x square equals to 4 times py. Then this parabola opens up if p is positive, opens down if p is negative. Focus lies at point 0, p. Directrix is y equals to negative p. Axis of symmetry is y-axis, and the endpoints of the focal chord is at plus minus 2p, p. Similarly, for the horizontal parabolas, the equation of horizontal parabolas can be written as y square equals 4 times p times x, and this horizontal parabolas opens to the right if p is positive, opens to the left if p is negative. Focus is at point p, 0. Directrix is x equals to negative p. Axis of symmetry is x-axis, and endpoint of the focal chord is at p, plus minus 2p. Similarly, parabola in the focus directrix form, where vertex is at hk and p designates the focus, the key features are as follows. So here, in the first one, vertex is at origin, and in the second, vertex is at hk. So then in vertical parabolas, our equation is x minus h outside is square equals to 4 times p times y minus k, where opens up if p positive, opens down if p negative. The focus is at the point h, k plus p. Directrix is y equals to k minus p. Axis of symmetry is x equals to h. Endpoints of focal chord are at the point h plus minus 2p, k plus p. And similarly for the horizontal parabolas. Awesome. Now with those key features of the parabola, now let's do some example. Example 1, find intercepts and the vertex of the parabola. The given parabola is y equals to 2x square minus 8x minus 10. And sketch the parabola. I hope the question makes sense to you all. Now let's begin the solutions. Since the coefficient of x square is a positive, this parabola opens up. So next, let's find the x-intercept. Put y equals to 0 in these equations and solve for x. So put y equals to 0. So we have 2x square minus 8x minus 10 equals to 0. Since this is quadratic equation in x, so we can factor in the next step. First factor the 2 out. Then we have x square minus 4x minus 5 equals to 0. And we can factor x square minus 4x minus 5. This equals to x minus 5 times x plus 1 and equals to 0. The product of two factors equals to 0 implies each factors equals to 0. So either x minus 5 equals to 0 implies x equals to 5, or x plus 1 equals to 0 implies x equals to negative 1. So we found the two x values, that is x-intercept are at 5, 0 and negative 1, 0. I hope this computation makes sense to you all. Next, for y-intercept, means to find the intercept along the y-axis, we put x equals to 0 in the given equation. So put x equals to 0, so first term disappeared, second term disappears, we have y equals to negative 10, hence the y-intercept is at 0, negative 10. Next, let's write the equation of parabola in a transformed form. This is the given equation of parabola. Y equals to 2x squared minus 8x minus 10. The next step, pull the 2 outside. Then inside the parenthesis we have x squared minus 4x minus 5. And from this step to next step here, in the next step I want to collect the x terms together and the constant together. So here 2 times x squared minus 4x, 2 times x squared minus 4x, and this spot is just a blank spot. This is the magic number. I'll tell you how I got this number. And the next term is 2 times minus 5, which is minus 10. Then let's come to this inside the parenthesis here. Then this magic number, so this magic number equals to the coefficient of x divided by 2 and square, and put this number here as a magic number. So here coefficient of x is negative 4 divided by 2 means negative 4 divided by 2 equals negative 2, and square the negative 2 gives us positive 4. So this positive 4 here. So we put the positive 4 here. Now to make these equations balance, I need to I add 4 here. That means I need to subtract the 4, but actually I am subtracting this 2 times 4 because I am subtracting outside the parenthesis. So I am subtracting 2 times 4, which is negative 8 here. I hope this algebra makes sense to you all. Then in the next step, the 2 as it is, inside the parenthesis, this expressions x squared minus 4x plus 4 is simply the binomial x minus 2 outside is square. And then minus this constant, negative 10 minus 8 becomes a negative 18. Now we have these equations in transformed form of the parabola. So now let's compare these equations to this form, y equals to a times x minus h outside square plus k. Then the vertex is hk, which turns out to be 2 comma negative 18. So 2 comma negative 18. So what we are finding here, we are finding intercept and the vertex. So we found the vertex. Awesome. And let's sketch the parabola. This is the sketch of the parabola, which opens up, whose vertex is at 2 comma negative 18. This parabola intercepts the y-axis at 0 comma negative 10. This parabola intercepts the x-axis at 5 0 and negative 1 0, and that's it. So I hope this makes sense to you all. Now let's move on. Let's do example 2. Find the vertex, focus and directrix for the given parabola. The equation of parabola is x squared minus 10x minus 12y plus 25 equals 0. And finally sketch the parabola. Let's begin the solutions. Rewrite the given equation of parabola in the standard form. We have x squared minus 10x plus 25 is simply x minus 5 outside square, and 12y just take to the right side, which is here 12y. So now compare these equations to this form, x minus h outside square plus 4 times p times y minus k. Then we got 4p equals to the coefficient of y, which is 12. So divide both sides by 4 gives us p equals to 3. Since the sign of p is positive, that means this parabola opens up. Also h equals to 5 and k equals to 0. Hence the vertex hk equals to 5 comma 0. Focus is at 5 comma 3. Directrix is y equals to minus 3. I hope this computation makes sense to you all. So next, for length of the focal chord, by the way, focal chord is the line segment through focus parallel to directrix and has endpoints on the graph. So for example, in the graph here, I'm talking the line here, which passes through the focus parallel to the directrix, and the endpoint of the focal chord lies at the graph here. So I'm talking the line here. I hope you are following me here. So here endpoints of the focal chord are with this formula here, turns out to be 11, 3, which point is here, and -1, 3, which is here. These are the endpoints of the focal chord. Hence the length of the focal chord is 12. So from here to here is 12. So it makes sense, right? From origin to here is 11, and this side is from origin to 1. That means the total distance of this focal chord is 1 plus 11, which is 12. Great. So now let's move on. Let's do example 3. Find the equation of the parabola in standard form with focus at 0, -5 and directrix y equals to 5. Let's begin the solutions. So by formula, since focus is 0, p, which is given to us, which equals to 0, -5, we have p equals to -5. Since the sign of the p is a negative, that means this parabola opens down. And vertex is at hk equals to 0, 0, origin. Also, 4 times p equals to 4 times -5, which is -20. And consequently, the equation of the parabola is this is the standard form. X minus h outside is square equals to 4p times y minus k. Since h is 0, k is 0, 4p is -20. So this turns out that x squared equals to -20y is the equation of parabola. So now let me visualize here. Visualizations here. So the parabola opening downward, vertex is at origin, focus is at 0, -5, and directrix is at y equals to 5. So this is the sketch of the parabola. Great. So we finished these sections, the parabola, as well as we finished the chapter 9, the conic sections. In our next class, we will start sequence and series, chapter 10. Thank you.